48. A 0.4 kilogram pendulum bob passes through the lowest part of its path at a speed of 3 meters per second. A. What is the tension in the pendulum cable at this point if the pendulum is 80 centimeters long? So to solve this problem at first, I made a diagram and labeled all the givens that was given. Please note that the 80 centimeters I converted into 0.8 meters because that's the units I want, and I showed which directions were positive in the x and y direction. Then I labeled the forces on the pendulum, so the weight going downwards and the tension from the string upwards. Having done my diagram, I can begin to solve. So I'm solving for tension. So I'm using the sum of the forces in the y direction equals tension minus weight equals mass times acceleration. Then I'm substituting just the letter A with the centripetal acceleration formula because acceleration is acceleration. So I'm just assigning more values to it to solve, so it's not an unknown. And so plugging in those values, we only have one unknown, tension, so we can solve for it. And you should get about 8.42 newtons. And B, when the pendulum reaches its highest point, what angle does the cable make with the vertical? So in the green, I labeled the pendulum at its maximum point with theta being the unknown angle with respect to the vertical. So the length of the string is still the same, 0.8 meters, and that's the hypotenuse. So knowing that, we can label the other two sides appropriately with cosine and sine. Notice that the distance when it's at the vertical distance when it's at its maximum is shorter than the distance when it's at its lowest point because it goes up as well. So that's gonna be our y later on. Just the difference, 0.8 minus 0.8 cosine theta. So then use conservation of energy. So the energy at the lowest point equals the energy at the maximum point. So kinetic energy equals potential energy. 1/2 mv squared equals mgy. And plug in the values, like I said, y will be 0.8 meters minus 0.8 meters cosine theta. And then we'll just solve for theta because it's our only unknown. And you should get about 64.8 degrees. Now we can move on to part C. So we had to draw a new diagram for this just due to it's a little bit more complex. So we're going to draw a second triangle because when you label the forces, you notice that the tension is diagonal and then weight is directly down. So we're going to want to make it's vertical, quote unquote, vertical component, this component, we're gonna find out that one. So and the two theta values are the same. So we can use that value that we solved for in part B to solve. So again, mg is the hypotenuse, so we can appropriately label the other two sides and then begin to solve. Saying the sum of the forces when it's at maximum, solving for the tension in the string at that point. So it's going to be the tension minus the weight cosine theta equals mass times acceleration, but the acceleration is 0, so that entire side is going to be 0, so this is going to be tension equals mg cosine theta, and then like I said, we found the theta value in part B, so plug that in, and then we should get approximately 1.67 newtons.